Hello, good afternoon, Sovorn. Sovorn, I guess you may start.
All right. Hello, everyone. Can you hear me clearly? Hello.
Yes, yes, we can hear you.
Right, let me leave this chat button here. All right. So shall we begin now?
I guess, I guess.
I will share my screen.
Uh-huh.
Wait. Hello, sir. So who's the one recording this video? Because if I recording, it might be a little slow for my computer to full-time presence and show the demonstrations. Hello, sir. All right. Okay. That's cool. All right. So, all right. You guys can see the screen, right? I just want to double check. All right. So I can start the presentation now. All right. Loading, loading. Okay. All right, so good afternoon, everyone. As you may have already known that today I'm going to be presenting you about my final year projects, which is about the real-time face recognitions based on the convolutional neural network, or in short, it's in CNN. So what do we have today is we'll walk you through the introductions of the project, methodologies and algorithms, and show you the tools that I use to implement this project. And then I will demonstrate my project. Without further ado, let's look at the introductions. But first, let me do a quick project and start introductions. My name is Sovorn Chea. I am a senior student from Management of Information Department and Information System Department. I'm interested in data science and computer vision field. That is why I decided to do a computer vision project for my final year projects, uh, which is the real-time face conditions. So the goal of this project is simple. We build a system that can recognize human face and be able to tell who the person is. So now let's begin by discovering more about the recognitions. In the world of recognitions and authentications, there are many ways that can be used to recognize people or authorize that the person is actually the real one or the one that owns what they claim to be theirs. Traditionally, people use the passwords and account names, which they have to remember every time they want to use it. And in addition, this method was very insecure. As we have known, like hacker can just uh, get easily into someone browser or the insecure sources that you have visited on your browser and get your credentials. Yet for the last 5 years, there are a few new methods that have been introduced. We call the biometrics method. So what is the biometrics method or science or recognitions? This is like the science that study the ability to distinguish individuals based on their measurable biological or behavioral. In here, like we have like fingerprints, iris, or palm, or even our face. But among all of these biometrics indicators, face recognition has turned out to be the most deeply studied area for the past decades due to its distinguished characteristics. But why like face recognition so special? Here I give you some popular uses of the face recognitions. Firstly, it's about the access control. For the access control, the recognitions can help control access to personal devices such as your mobile phones or computers. Also for the residentials or the vehicles or even entering the office. And then we also have the attendant checking. With the help of the face recognitions, it became possible to efficiently track the attendant at a large gathering events or at the office or even in classes. We also implement it in the for the marketing purpose. It's like a new source of direct insights. Like some retailers in developed country already implemented the recognition system to know which product the customer have an eye on it, so that they can place the product on the front row or in the back rows in their store. And we also face recognition also been already been implemented in the banking sector. As we can see for our ABA mobile phone right now, they use the face recognition for the authentication method. But in some developed countries, uh, right now they also use it to double checking when you go into depositing or withdrawing money from the ATM to clarify if you were like really the person who owned the card, the bank card. And lastly, is use it for the public security. For this, it's like a new arrival of the new powerful tool we can take like China as an example. Their surveillance system right now can recognize human face. Their Chinese faces up to 1.2 billion people in the public places. All right, so now as you already familiarized with the things that the face recognitions can do, let's look at the basic process of building it. All right, here is a very simple face recognition process. We start up with an image data set like human face, but in my project particularly I use the frontal face uh, for the data sets, and then like we do a face detections. Like in one image you have to detect where the face is, and then capture that frontal face, and then we do a feature extraction, which is to gather the facial characteristics. Then we can be able to verify and recognize uh, face. All right. So here's the process of face recognitions, and here is a few algorithm because to be able to do the recognize or detection or recognition task, there are many algorithms that we can use, and here I only pick a few. The first one is the geometric features. So the goal of this geometric features algorithm, it is to find like a set of representative features of the human face, like we see in here, like to find this representative, which based on like our mouse positions or nose length or width or position of eye or even the eyeballs. And for the second one is eigen faces. This one, it's like it's an appearance base. In here is a geometric base. Here is appearance base. We seek to capture the variation of a collections of the face image, and then use the information to encode and compare the image, the upcoming image of individual faces in a holistic form. It's like you take that individual image and create a ghost-like image, as we can see here. And for the another one that we have here is a local binary pattern histogram. This one, like this method is used to describe the textures and the shapes of an image in a digital form. Like we only store 0 in 1 while converting from the image to this form. But for my final year projects, I choose to use a deep learning approach, which we call it the convolutional neural network. So what is the convolutional neural network? This is one of the deep learning algorithms that have proven very effective in an area of image recognitions. CNN is a type of feed-forward neural network. We can see here, like we go like this from the image to the output that made up of many layers, and like each input image will pass through a series of these convolutions layer with the filter. I will explain it later one by one, and the pooling and the fully connected one. And then the last step, like it uses the submark activation functions to classify an object, like in this case, like to classify the output, what if it is a person 1 or a person 2 or a person C. This is like it's if some of you here already know the concept of neural network, it quite similar. It also like the neural net or deep learning, but the difference that from CNN and a normal is that the normal neural network that we use for problem for our application, it take in like a highly structured numerical data like our age, our height, our weight. But specifically for convolutional neural network, it work very efficient on the image. So now I will like go through one by one, like to give you a brief overview of each layer, because like too specific, some of you might not be interested in. And then we can go into the demo part. So here we have three layers: convolutional layer, polling layers, and fully connected layers. So here's the convolutional layer. So this is like an image filtering layer. As we can see here, this number is represent an image. Let's say it's represent this image right here, and then we convert it to number. Like possibly it here from 0 to 255 because of the pixel color. And then we have the filter or canal that we call it. And this canal, it produce another feature map, because like what the convolutional neural layer does is it's to extract the features from image. So but like while extracting the feature, like it preserve the spatial relationship between pixel. Here, imagine if we change one pixel or two pixel here, this oh, this image will be destroyed or ruined, or like because we make some adjustment, so there would be like something here in his cheek if we do some adjustment here. But with the filter in the convolutional like convolutional layer, it creates at the feature map of this image like without losing its property. Like the pixel are still related to each other, because like pixel in here, when we convert from image to pixel, it interrelated. So if we change one, it will affect another. But in this convolutional layer, that is to filter an image without losing its original property. The second layer is the pooling layer. The pooling layer is another building block of the CNN, but it's simply used to reduce the dimensionality. Dimensionality here, I mean like the number, the dimensions of an array. Picture this one in an array form, this image, this array form. So what it does is also like used to reduce the dimensionality and also reduce the amount of parameter and computational in the neuron. Like here is the original array. When we apply max pooling 2 by 2, we only left with the 2 by 2 array. And here there's two types of max pooling. First is the max pooling. Another one is an average. This one like 2 by 2 size, like here's the pooling 2 by 2, and then we only select the maximum value. Whereas here we do 2 by 2 like here, but then we select the average. It's quite difficult to go into deep. Just remember that this layer, because like in one image, in reality, one image is quite huge, like a thousands times a thousands pixel image. And then we have like, if we put it through the neural network programs, like it will takes a lot of times or a lot of computational work to do. That's why like the convolution layer and pool maxing layer is to reduce the size of reduce like the dimensions of the array, but still maintain its partial relation between pixel, so that it still like preserve its own property from the original image. So the last one is fully connected layer. This one, like it take the output from the previous layer, and then we flatten the array into like a one single vector, so that it can put into the neural network. Here it's like a normal neural network. So for the concept of neural network, I will not explain it too deep, but like to make it easy to understand, put it simple, just like imagine here is an image, and then you convert it into the array and flatten it into a one single vector, and then you pass it through this network. So what this network does is, in each hidden layer, think of it as an pattern discovering. So let's say hidden layer one, it's discovering like one pattern like an eye of a human. The hidden layer two is a nose or a mouth or something. And after this pattern, in the last one, which is the output layer, like they map up or they finalize, and then they can tell us what is the image is about. Is it a person two? Is it a person three? Is it a not a person at all? All right, so here are some tools that I use for these projects. The most important one is like I use a Python programming language for these projects because Python provide a lot of it's convenient and a lot of available library for this computer vision field. And I also use OpenCV for capturing an image or access to the webcam from my computers. And then we have the NumPy, which is a multi-dimensional array computing. As we see earlier, there's a lot of number in huge array. So NumPy is work pretty fast with those multi-dimensional array. And then I use TensorFlow for the data flow of the neural network. And last but not least is Keras. It's like another open source platform that work on top of TensorFlow. I use this like to get a CNN model. All right, so I think that is all. It's time for demo. Oh, 20 minutes. All right. Oh, I think before I go into demo, yeah, it's all right. I still have you here. All right. Here, I just want to show a little bit about my data set. Here, I capture the frontal face of 4 individuals, and I capture 100 each. So the picture of Dr. Ricardo, we have 100 pictures. Mine is 100 and Sotain also on in here. Here is my brother. So this is a total of 400 image for my data sets. All right, so here's the result. All right, so what it does is, all right, what it does here, it will recognize that this is me, and here's the percentage of the likelihood that they predict that this is me. Because we only have 4 people. Unfortunately, I'm at my hometown, so I cannot. If I'm at Phnom Penh, I might be able to show Dr. Ricardo face to see if it worked fine or not. But here you can see like it a little bit quite slow, and the number of prediction here, it keep changing. Why? Because what this program does is to here is you see the green rectangle. Here is the detections method, which means giving the image that I'm presenting right now, it will find where is the human face. And then once it found, it will draw a green rectangle here. And then it only takes the frontal image, which means the image inside this green block, this green rectangle. It take this face inside the green rectangle to do the recognition test. So first, you have to detect where the person face is. Then once you found it, you only capture this area to do a recognition path. So here's my database. What? All right. Here I capture 100 image of each person. because I need image in order to train uh, for the program to understand later on if it is me or the other. We can see here if I put here is they show another person or oh no, I want to see here Dr. Ricardo. Oh no, all right. Probably like it's because of the poor light conditions. Uh, this is like not really a good algorithm one, but like I'm trying like to for the detection for this pet detection I use the uh, uh, library, but for the recognition part like I write it my own function, not my own functions, like I write the program myself to recognize human face based on the deep learning, the CNN model that I mentioned earlier. All right, I think that's all because it drained my battery for this recognition. We can stop here. Let people ask questions. All right, I believe it here. All right, I think that's all for my presentation. What if you wear glasses? All right. We, we find the glasses. Oh, I never tested it with glasses and I don't know if I have one right now. I don't think I have anyone. I only at home. That interesting. I never tested with glasses. Oh, but like because because my data consists of uh image face that has no glasses. So if you wear glasses, it might I think it still be able to detect your face, like detect your face, but I'm not sure if it be able to recognize people. So oh, for the mask it will not work because like for the mask like they use they use they have to create they use another algorithm for the mask recently due to like this coronavirus outbreak. People also, I saw some news on internet like people they uh, build the face recognition with that mask, which means you can recognize people with the mask, but you cannot tell that if that who's the person, just to know that face without mask and detect face with mask. Only like for the detection problem, not the recognition one, because you cannot be able program cannot tell like who you are when you wearing mask. It cover up half of your face. And any more questions? The futures, uh, 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 I'm not in algorithm, uh, not applications. For my point of view, like for the face recognitions in terms of algorithm, there's a lot of room for improvement. But right now, like think of the computational power, it's enough right now. We have the cloud computing that can compute up to like billions of uh, transactions in a second, and so we have no problem with the computational powers, but in terms of algorithms, like because like in the deep learning in the deep learning area, there is no a perfect algorithms. Like we have to test it every few months to see like if this algorithm still works for these kind of problems, or they add a new form of algorithm. Because like the difference between algorithm in the deep learning field, it's not about like how you compute thing. It's about like building these architectures, like architectures in here, like in his architecture, if you want to have like two convolutional layer, two McFooling layer, or in the fully connected layer, what hidden layer do you want? And that is where like people started to discover a new architectures for this network. Uh, can I now be that you can show the positions of each face or not? What do you mean by positions? The level, all right. Uh, it does. Wait. It actually also can detect multi-face, which means if certain standing next to me, it will detect both faces at the same time and show the accuracy level as well. Here, Pirom here, like you can see this is like the accuracy. It's like 95 or 96. This is keep changing because like if I move a little, because as I mentioned it earlier, it will detect the face and then it will take this area in order to recognize. So in every seconds, like the frame keep changing, it will getting new input. So it will predict a new. As I move my face along, sometimes it will show the other person name. Here you can see like 60%, 70%, 90%. Because like it a little bit slow. It's not like the supercomputer that we can use to run it. Din, din. Can your application do the face scanning in the dark place? All right. For the light learning conditions, I'm not sure if it's can still work because the uh, like the data set that I used to train is like in grayscale. It's not like a shoot data. We can look here. It's quite small. It's a 32 times 32 pixel and it's a grayscale. So I do this on purpose because if I use like a colorful, which is a three-dimensional array, and a large, let's say, 1,000 times 1,000 pixel, so the workload, the computational workload will be like extremely high that my computer cannot run it in real time. Like if I do it only like to provide an image, and then like the output of the program suggests that this is Dr. Ricardo, this is Sovorn. That is would be an easier one that I can use like the good quality one. But because like I wanted to do in real time, which it has to capture in every captures the frame from the video in every second. So if I uh, uh, do it in the good quality image, it would be my computer cannot be able to run it. And actually, like in here, while the program is running, when it capture it, it also convert those image into the grayscale, because like uh, otherwise it will not do a good job, since my database is in 32 by 32 and in grayscale. I have to convert and normalize my new coming image into the same format. All right. And how many samples should be enough for one recognition, for one face recognition? For that questions, uh, I don't have the final answer, because like as I mentioned earlier, it's based on like your goal. When you build an application, you have to set it. As I mentioned, because like I think of like the computational power of my own computer laptop. That's why I choose like a very small and a grayscale image. And for, let's say, if you have a good, like you can do it on the cloud, you might want to use a three-dimensional, like the colorful pictures, uh, and then like with the good quality one, so that it can do a better job than this. And for the numbers of uh, sample, you have to test it by your own, because like uh, it doesn't matter if it a millions or it a thousands. If like uh, you reach the point that with this sample my algorithm work quite fine and provide like up to a 95 accuracy, so you satisfied with it, you can you you can stop gather more data. But like if with the within the 10,000 sample, it's still not, you're still not satisfied with the result, you can add more. Or another way, we can use the data augmentations. What the data augmentation do is to take your image, rotate it like 45 90 degree or something, flip the image into left, into right, or like string your image or string your image, so that you be able to have more side without going to gather it. Just apply the data augmentations in case like we don't have enough sample. But like for the total number, as I mentioned, I will not have the final answer for you. You have to test it by your own when you build applications. Uh, that is that will not work, because like the twin problem, it still cannot, it's still 100% confirmed like in the real world face recognition right now. So that a very good question, like to work with the twins. Uh, Maybe I can take that uh, subjects for my master degree to work with twins. So, any more questions? Or we can end the session here.